This is physical science again, and today we will be talking about waves. Yan, waves. All right. So, if you're thinking of some kind of waves like ocean waves, okay, and other waves, okay, then you're right. So, ocean waves are examples of waves, actually, di ba? Yan. Tapos, ano pa ba yung mga ibang waves that you can think of? So, what is a wave? Basically, what is a wave? So, a wave is a traveling disturbance that carries energy from one place to another. Okay? So, it's a wave. So, sa ibang definition, sabi, it is a disturbance with which energy is transmitted. Okay? So, either way, they both refer to wave. Okay? So, sabi dito, it's a disturbance. Diba? Para bang, if you're holding a rope, for example, nakatali yung isang end ng rope sa poste and then hawak niya yung isang end. Pag hawak lang, it's steady. It is at rest. Di ba? It's not moving. Okay? But if you start jerking the rope, okay, by moving your hand up or down or forward and backward, okay, then it creates a disturbance. Okay? At yun yung disturbance na yun, it travels, okay? Yan, kasi um, pag nag-move yan, okay, there's going to be energy. Kasi yan, sabi nga natin, where do waves get their energy? Kasi sabi dito it carries energy from one place to another. So where do they get the energy? Okay? Yeah. So when you jerk the rope or move your hands up and down or forward and backward, okay, you are creating a vibration. Okay? So vibration is any movement that follows the same path repeatedly. Yun yun. So merong path, there is movement that follows a repeated path. Okay? So yun yung wave. Okay, so and then an object that is vibrating. Okay? Kung may vibration, may motion. Okay? In fact, vibration is one of the kinds of motion that we've learned in addition to translational motion and rotational motion. So vibrational motion is a motion. Okay? And an object that is moving has energy. Diba? Sabi ng kinetic energy, something, energy that is by virtue of motion. Ayan. So, a vibrating object gives off some of its energy to the nearby particles, okay, causing them to vibrate as well. So these particles in turn give off energy to the particles to the next, and then, and so on and so forth. Okay? Ayan. So, that's it. This movement of energy from a vibrating source outward is what a wave is. Yan. So, yung movement of energy from a vibrating source outward is a wave. Alright? So, all waves have vibration as their source of energy. So, yung vibration ang source ng energy for all waves. Okay? So, yan. Kagaya nga ng binanggit ko kanina, when you tie a rope, okay, and then you move your hand up or down or back and forth, you actually created a vibration. And then the energy from your hand, okay, is transferred to the rope. Okay? Yeah. So when you move your hand na naka-attach sa rope, the energy from your hand is transferred to the rope and then the particles in the rope, yan, dire-diretso na parang meron ng tinatawag na domino effect. Okay? So now electric charges, when they vibrate, they create a light and microwaves. Okay? Ayan. Kasi pag merong vibration, okay, it's going to create something, di ba? And then another one, energy is given to the air by the vibration of a guitar string, and then that creates a sound wave, right? So that's where it's actually from the vibration where waves get their energy. All right? So waves through matter and space. Okay, so let's talk about medium. Okay, what is a medium? Medium is a matter or substance through which a wave is transmitted. Okay, so there are waves that require a medium to be transmitted. Like for example, dun sa example natin na rope, di ba? Or other examples would be water. Okay, so water is the medium for ocean waves. Okay, and air is a medium for sound waves. Okay, yan. So all matter, whether solid, liquid, or gas, can act as a medium for which wave can be transmitted. All right. Now, uh, mechanical waves are the waves that actually require medium for transmission. Okay? Mechanical waves yon. So we'll be talking about mechanical waves, right? For now, when we speak of medium. So there are particles that you affect to vibrate so that it would create a disturbance in the form of a wave and transmit energy. Okay? So mechanical waves ang tawag doon. So mechanical waves are waves that are caused by a disturbance or vibration in matter. So kung walang matter, okay, then there will be no waves. Okay? So that matter, sabi ko nga, could be solid, liquid, or gas, or here even plasma. Okay? So these waves are waves that require medium for transmission. Okay? And to figure out what mechanical waves are, okay, so we have this picture here, all right? So yung horizontal line na yan, you imagine that to be the rope that is at rest, okay? Yung hawak ninyo na rope, okay? Naka-rest lang siya. And then you start to move your hand up or down, okay? So you created a disturbance, okay, on the rope. Okay? Ayan. Kaya, ayan, nagkaroon ng vibration of matter which is in the form of rope here. And then it creates a wave. Okay? And then that wave transmits energy kasi may repeated, okay, pattern of path. Okay? So, yan yun. Alright? So, from rest to the maximum height of the wave, that is the amplitude. So ito yung mga iba-ibang characteristics of a wave. And then we have the wavelength, okay? And then the complete wave cycle. So with this picture, you have one and then two cycles. So one complete cycle is where there is one crest, okay, and one trough. The highest point on the wave, you call it a crest, and the lowest point, you call it the trough. Okay? And then the time for one cycle to take place, you call it the time period of the wave. Okay? Or the time, mamaya, pag-usapan natin kung ano yung mga yan. Alright? So I want you to remember this figure so that it would be easy for us to imagine when we talk about these characteristics of waves. Okay? So what are the characteristics of waves? First, we have amplitude. Okay? Amplitude, or like I said kanina, it is the maximum or the greatest movement from rest. Okay? So it is found by measuring the distance from rest to a crest or from rest to a trough. So yun ang amplitude. And ano yung implication ng amplitude? Okay? So the amplitude of a wave indicates the amount of energy carried by the wave. So we say that as energy increases, particles of the medium are moved a greater distance from rest. So that results to the amplitude to be increasing also. Okay, so with this, we can say that as energy increases, the amplitude also increases. Okay, or a great amplitude implies a great energy carried with the wave. Tama ba? Okay, so anyway, so that's amplitude. Okay, now wavelength is another characteristic, which is the distance between two consecutive crests or between two consecutive troughs. Although it can also be measured from any point on the wave as long as it is measured to the same point on the next wave. So, ibig sabihin, you could decide, halimbawa, you have two waves, diba? Two consecutive waves, okay? You can pick out any point from the first wave and the same point on the next wave, okay? And you measure that, that gives you also the wavelength, all right? So, yun yung wavelength. And it is symbolized by the Greek letter lambda, okay? And usually is measured in meters or in centimeters. All right? So yun yung wavelength. Now another one, we have the time period. The time period is the time required to produce one complete wave or cycle. Okay? Now, one complete wave is produced by one full vibration of the vibrating body. Okay? So, kung merong up, merong down. Yun yung isang complete cycle. Alright? So, we can say that the time taken to complete one vibration is known as the time period, which is denoted by letter T and measured in seconds. Alright? So, yan yon. Now, another characteristic is the frequency. Ano yung frequency? It is the number of complete waves or complete cycle per unit of time. Okay, so ilang wave cycle over a certain period of time. That gives you the frequency. Okay, now every complete wave has one crest and one throw. So therefore, frequency is the number of crests and throws produced per unit time. Alright, so that could be another way to describe frequency. And the unit used to measure a wave frequency is called the hertz. Okay, that's the symbol. You probably have heard of the word 97.5 or 97.7 or 107 point something kilohertz. Okay, so these are the radio frequencies. Okay, pag nilipat mo to another frequency, so it gives you another channel, parang something like that. Okay, so these are frequencies. Okay, wave frequency. And a frequency of 1 hertz is equal to 1 wave or 1 cycle per second. So we can say that 1 hertz is equal to 1 wave per cycle, or simply 1 wave per second or 1 cycle per second. Okay? Yan. Okay? So the frequency of a wave depends on the frequency at which its source is vibrating. Okay? So depende sa lakas ng vibration yung dami ng frequency, okay, of the wave. Alright? O syempre, pagka ginerk mo yung rope ng mabilis, di ba? Mabilis. Okay? So, madaming frequency. Pero kung medyo mabagal lang, alright, then there's lesser frequency. Okay? Yan. So, there would be lesser waves over a certain period of time. Okay? So, another property, okay. So, before we continue, let's take a look at the relationship between time period and frequency of a wave. Okay? Ayan. So, may relationship yan. Right? So, the time required to produce one complete wave is called the time period of the wave. So, supposing that the time period of a wave is t seconds, and in t seconds, the number of waves produced is 1. Okay? So, in 1 second, the number of waves produced will be 1 over t. Okay? O, kasi sabi natin, in t seconds, wave is 1. So, 1 over t. So, but the number of waves produced in 1 second is called its frequency. Okay? So, how many waves are produced in a single second? That is the frequency of the wave. Okay? So, therefore, F is equal to 1 over time period, or in symbol, F equals 1 over T. So, yan yun. Alright? So, where F is the frequency of the wave, and then T is the time period of the wave. So, that's the relationship between the two. Okay, so, sometimes, instead of saying F, you just say 1 over T. Okay? Or if there would be 2 waves, then you say 2 cycles per second. Okay? Or 5 cycles per second. So, depende kung ilang wave cycles would occur in a single second. So, yun yung relationship between time period and frequency. Okay? Now, another property or characteristic of wave is velocity of wave. Okay? So, sabi natin, all right. So, what is the velocity of a wave? So, it is the distance traveled by a wave in 1 second. Okay? So, you call it the velocity of the wave or speed of the wave. And it is represented by V. O, di ba? So, yun naman yung ating symbol ng velocity even when we were talking about straight line motion, di ba? And the unit is still in meters per second. Okay? Yan, alright? So, the speed of a wave is determined by the number of waves passing at a point in a certain amount of time. So, ibig sabihin, it's the frequency, the number of frequency, okay, over a certain period, and the wavelength of the wave, okay, or the length of the wave. So to put that in clearer expression, we say speed is equal to frequency times wavelength. And then mamaya titingnan natin yung relationship ng tatlong yan, bakit naging ganyan, okay? Kasi ang speed, sabi natin, distance over time. Pero bakit naging frequency times wavelength, okay? So we will see that just a little later. But for now, using that expression, we can illustrate that with this example. Okay, so if a wave has a frequency of 4 hertz and a wavelength of 2 meters, then using this expression, the speed of the wave is 8 meters per second. Okay, now, if the frequency of the wave were increased to 8 hertz, the wavelength would decrease to 1 meter. Okay, so if that's the case, 8 hertz times 1 meter is still 8 meters per second. Okay, so ibig sabihin, the velocity of the wave was maintained. Okay, now that would mean that if the frequency becomes 16 hertz, you would expect the wavelength to become 1/2, so that the resulting speed would still be 8 meters per second. Why is that so? Why is that? Because in a given medium, the speed of a wave is constant. Okay? And that is only in a given medium. The speed of a wave is constant. Okay? Now, an increase in frequency, therefore, requires a corresponding decrease in wavelength. Okay? So what do you think would happen if to the frequency if the wavelength were increased? So expectedly, you expect it to decrease. O, di ba? So that the constant speed would remain. Okay, so that means the velocity of a wave depends upon the medium through which it is traveling. It does not depend on the source or the speed of the source. Like, for example, let's take a sound wave, for example. Okay, you hear a sound from a traveling airplane and from clapping of a hand. Okay, now if both sound waves are traveling in the same medium, then they will have the same speed. Okay, so hindi siya nagdepende sa bilis nung eroplano, takbo nung airplane for the yung sound ng airplane, di ba? But it depended on the medium. So it does not depend on the source of the speed or the speed of the source. So it depends on them. So the velocity or the speed changes only if the medium is changed. Okay? Yun lang. All right. Now, one property of a medium that affects the speed of mechanical waves. Okay? So this is true only for mechanical waves because they can be transmitted through a medium, all right? So one property that can affect the speed is the density of the medium. Okay, so what is density, by the way? Sabi natin, it is mass over volume. Okay, so ibig sabihin, the greater the mass, the greater the density. So if there's a greater mass, that means there's greater inertia. So that is why pag sinasabi natin, the more dense the medium, the slower the speed of wave in that medium. Okay, why? Because a denser medium means more mass, okay, which results to greater inertia. Okay, so and anong sinabi natin about inertia? It's a property that resists, okay, a change in velocity. Kaya dito, it is harder to get all the particles of a denser medium to respond to the energy of the wave and start moving kasi there's greater resistance. Okay? Yan, di ba? We talked about inertia and force in our discussion of the laws of motion. So you see, so even in the velocity of wave, the laws of motion also applies. Okay? Right. So with that, okay, let's take a look at the relationship between velocity, frequency, and wavelength of a wave. Okay? So sabi natin, velocity is the distance traveled or distance covered, okay, over a certain period of time or over time taken. Okay, now, with the velocity, okay, of wave, v can be equal to lambda, which is the wavelength, over t, which is the time period of the uh, wave, okay? So t here is the time taken by one wave. So therefore, the speed of a wave or velocity of a wave is equal to f times lambda. Ay, bakit naging f? Nasaan na yung t? We have seen earlier in the relationship of time period and frequency that frequency is equal to 1 over t. So itong equation ito could be written as V is equal to lambda times 1 over t. Kaya yung 1 over t na yun ay frequency. So that's why we put here F. Okay? So this formula here now where V is equal to F times lambda or velocity of wave is equal to frequency of the wave multiplied by the wavelength. This formula is known as the wave equation. Okay? All right. And with that, we say that the variables are V is the velocity of the wave, F is the frequency, and lambda is the wavelength. Okay? Yeah. So we have seen that. Velocity of a wave is frequency times wavelength. Now you know why it's F, okay? And why the unit for velocity is still in meter per second. So kasi itong F is 1 over T, so ibig sabihin 1 per second, and this lambda is in meters, so velocity would be in meters per second, okay? So with that, let us have a sample problem, all right? First, yan, so the velocity of sound in seawater is 1,531 meters per second. Find the wavelength in seawater of a sound whose frequency, of a sound wave whose frequency is 256 hertz. Okay? All right. So our wave formula or wave equation is V is equal to F times lambda. So this is our working equation to solve for the speed of the sound wave, okay? And substituting or rearranging because the problem is asking for the wavelength, so we say lambda is equal to V over F. And substituting the values, solving it out, we get the wavelength to be equal to 5.98 meters, all right? Okay, so the next problem would be this. A wave has a frequency of 10 hertz and a wavelength of 30 meters. What is its speed? All right. Now, I want you to do that on your own. And if you get the answer, type that down on our chat box. And as a follow-up question to the first question, if the frequency of the wave were 20 hertz, what would be its wavelength? Okay. Ayan. So you work on that and you type your answer on our chat box. Okay? And titignan natin mamaya at the end of the discussion if you got the correct answer. Okay? All right. So with that, let's continue. Now, what are the types of waves? Okay, so there are two types of waves. First, we have the transverse wave. Okay, so ano yung transverse wave? It is a wave in which the motion of the medium is at right angles to the direction of the wave. So meaning, the motion of the particle is perpendicular to the direction of the wave, okay? So we're talking of a particle here. So still, we are on mechanical waves, all right? Yeah, so that requires medium. Okay, so this is how a transverse wave looks like. Okay? So dito, sabi ko nga, kanina, di ba, you imagine yung rope na naka-stationary muna at rest. And then when you begin to move your hands up and down, okay, then the medium would also, what? Move. Okay? Yan. Parang pataas, pababa, pataas, pababa. Okay? So that would be the direction of the particle. Okay? But the wave is what? Going in that direction, horizontal. Kaya sinasabi natin, the motion of the particle is perpendicular to the direction of the wave. So yan yung transverse wave. Okay, now the other kind of wave or type of wave, is the longitudinal wave. Okay, so this is a wave in which the motion of the medium, okay, is parallel to the direction of the wave. Right? Parallel. So, ibig sabihin, the motion of the particle is to the direction of the wave. And this is how it looks like. Okay? So, in this picture, you can see that as energy is given to the particles, they begin to vibrate. So, the energy again starts with a vibration. Okay? But the vibration, instead of vibrating up or down, they vibrate backward and forward. Okay? So, back and forth yun. So in the process, there will be a space in the medium where the particles would be crowded. So ito yon, itong part na ito, yan, yan. They will be crowded. And there will be spaces in the medium where the particles are fewer. So kagaya dito. Kasi di ba pag nag-move forward, okay, ayan, okay, na-move yung particle forward, okay, magka-crowd yung particles. And then as they move back forth or backward, okay, mag-few. Okay, so parang sa spring, di ba? So, yan. Now, this is space here where there's more particles, you call that compression. And dito naman ay rarefaction. Okay? So, ibig sabihin, the movement is compression, rarefaction alternately. Okay? Yan yun. Okay? So, that's it. Okay. Yan. Alright. So, these are the types of waves. Okay. So, what we have been talking about earlier referred to the mechanical waves. Okay. So, this time, let's take a look at electromagnetic waves. Okay. So, electromagnetic waves are different. Okay. From the mechanical waves in the sense that they do not require a medium, okay? They don't require a medium for propagation or for transmission. Yun lang yung difference nila, okay? Now, this means the electromagnetic waves can travel not only through a medium, but also in space. So, whether there's matter or no matter, okay, they can be transmitted or propagated. Okay, so that is the reason why light from the sun can be transmitted to the earth. Okay? O kasi between the sun and the earth is a vast space. Okay? So probably nagkakaroon na lang ng material or matter sa atmosphere ng earth. Okay? But outside of that probably is a vacuum of space. And this is for this particular characteristic ng electromagnetic wave, this is the reason why they can reach the earth even in the vacuum of space because they do not require, okay, medium for transmission, right? So, electricity can be static. Okay, pag sabing static, steady lang. Like the energy that can make your hair stand on end. Pagka, halimbawa, mag-grab ka ng balloon, okay, in your hair, and then iangat mo yung balloon, yung hair mo will tataas, di ba? Magtatayuan. And then magnetism can also be static as it is in a refrigerator magnet. Okay. Now, a changing magnetic field will include a changing electric field or vice versa. The two are linked. We cannot separate them. They are linked. Okay. So, these changing fields form electromagnetic waves. So, yun yung electromagnetic waves. Okay. So, we'll be talking more of that next time. Okay. So electromagnetic waves are waves that are created as a result of vibration between an electric field and a magnetic field. So pag sinabi natin electric field, magnetic field, or electromagnetic field, these are regions in space, okay? And electromagnetic waves are composed of oscillating magnetic and electric fields. Oscillating or vibrating, okay? And it is a transverse type of wave. Why? Because the magnetic fields vibrate or oscillate perpendicular. Yung electric field and magnetic field components of the electromagnetic wave vibrate perpendicular to each other. And not only to each other, but also to the direction of propagation of the wave. Okay? And this is how it looks like. All right? So if this is the propagation of wave, yan yun, horizontal. Okay. So the magnetic field is, ayan, transmitted perpendicular to the direction of wave travel, okay, and also perpendicular to the electric field, okay. That is the travel. So you see, they are perpendicular to each other, and both are perpendicular also to the wave uh, direction. Yan. So these are the electromagnetic waves. Okay, now let me introduce to you now, although we will be talking much of this next meeting, yung electromagnetic spectrum. Okay, introductory lang ito for the next. Okay, so that para meron kayong aabangan next week, di ba? So electromagnetic waves are a continuous spectrum of waves. So it's continuous spectrum siya. Okay? So there's a lot of tawag dito, spectrum, okay? So that's why it can be separated into 7 groups, okay? So we will discuss that next time. And each group has the same frequency, wavelength, and energy, okay? Yan. Each group the same, but from group to group, they differ from one another. And this is how an electromagnetic spectrum looks like. Okay? Yeah, that's how it looks like. So here, you have the longer wavelength and lower energy. Okay? Spectrum. And here we have the shorter wavelength and higher energy spectrum. Okay? So you see that color there? So yan yung visible light. Okay? Yan, because light is the source for electromagnetic spectrum. Okay? So sunlight, yun sabi nga, is the source for electromagnetic waves. Yan. So not all wavelengths of electromagnetic waves in sunlight reach the Earth's surface. Okay? So the Earth's atmosphere blocks all the gamma rays, okay, and other rays probably. O kasi it has something to do. Yung blocking dyan, class, ha, not in the way that you're thinking ng block. Mayroong nilalagay na bagay para makaharang, something like that. Okay, so hindi ganun yun. Okay, it's another way. Alright, so now, the energy, kasi sabi natin, di ba, any disturbance or any wave carries energy with it. Okay, so the energy of an electromagnetic wave is given by E equals hv. So h here is Planck's constant. Okay, it's a constant value. And v is the frequency of light, right? So this shows that energy can be quantized, measured, and this concept, this discovery, okay, or this statement led to the discovery that light, okay, is not only a wave, but also a particle. Okay, so this now is the starting point of our discussion next week about the wave particle nature of light. Okay, so that's it for now. So that ends our discussion for waves.